Hello folks, this is your 2024 October-November paper 2 and the question number is 5. The question is concerned with the chapter current electricity. It says the first question is define electric potential difference. So it's about the energy transfer per unit charge from electrical to some other forms. It is especially if it is across the device, the energy transfer is also across the device. If it is across any two terminals, the energy transferred is also across those two terminals and so on. Our main stuff starts now. It says a power supply, three resistors here, and a component X are it was a great sneeze, great satisfying sneeze. Actually, in our country, in our culture, in our ritual, when we sneeze, we don't say sorry because it's not a matter of saying sorry or it's not a matter of saying excuse me. We say long live, or have a long life, something like that. And sometimes you also say Jew. Jew means it's okay. Don't worry, it's okay. Everything is okay, like that. So it's everything is okay with me. So I'm not going to delete this portion because I think it is natural to sneeze, and I just want to keep it that way. So component X are connected in the circuit shown in figure 5.1. The power supply has an electromotive force e.m.f of 230 volt. I'll name it as E, and a negligible internal resistance. The current in the power supply is 7A. So this is the total current here. So from here to here, the current is I equal to 7.0. So the first question is identify component X. So the symbol with this type of symbol belongs to the electric heater. So it is the electric heater. Okay, next. Show that the PD across the resistor of resistance 0.86 ohm. So this thing is 6.0 volts. So we have to find the PD here. So this PD, let's name it as V. So this V is equal to current into resistance. So the current here is given, resistance is there, so it should be equal to the current is 7.0 into resistance is 0.86 ohm. So its value should be equal to 7 into 0.86 equal to so it is 6.02 volt. So I can write it as 6.0 volt. Then determine the current I1. So I have to find this current. So in order to do that, let me name these terminals as A and B. Let me name them as A and B. So here the PD across this AB, I can name this VAB as VAB can be the PD across 2.4 ohm and X, or it could be given by the PD across this 170 ohm as well. So if I cross this path, it encounters resistors 2.4 ohm and X. If we consider this path, it encounters the resistor 170 ohm. So here I have to find this I1, but I don't know this. So what I do is, let me go this way. If I consider this path, then I have this I2 is equal to VAB divided by this 170. That's equal to and this VAB is equal to so this PD is equal to this EMF minus this PD. It's equal to E minus V. So it is E minus V by 170, and that's equal to E is 230 volt minus this V is 6 volt, and this is 170, and that becomes equal to 230 minus 6 equal to 224 divided 170 equal to this much. So it is 1 point lots of digits there, 1.3176 and so on. So I write it as 1.32 amperes. So the current here is 1.32 amperes. So now the current till here is 7.0. This is 7.0. some part goes here as 1.32, and this I1 should be equal to, now this I1 should be equal to 7.0 minus this thing, so it is minus 1.32. That's equal to so 7 minus 1.32 equal to, so this is 5.68 amperes. 5.68 amperes. 5.68 amperes. Now, yeah, calculate the PD across this component X now. So we have to calculate the PD across the component X. So component X is this. This is the component X. We need to find the PD across this component X. So for that, what I can do is, this VAB is there. This VAB is equal to, we found it as this. It is 224, something like 224 VAB, and we have some potential drop here as well. So what I can have is, this Vx is equal to VAB minus this thing, minus I1 into 2.4. So now VAB will be equal to, this VAB is equal to this thing, 230 minus 6. It's equal to 230 minus 6. Then minus I1 is equal to this much. We just got it, 5.68. 5.68 into this resistance is 2.4. So it should be equal to, this is 224 minus 5.68 into 2.4, like this. So it is 210. It is 210.368 and so on. So if I write the properties only, it is 210 volt. Now power dissipated in component X. So power is equal to, so this PD is like this. So power is equal to I1. So let me say it here. The power across this device X is equal to current into this PD. So the current is I1. So I1 into this PD Vx, and I1 is equal to this much. 5.68 into PD is 210. So this becomes into 5.68 equal to, so it is 1194.89. So if you write in 3SF, it is 1190. If in 2SF, it is 1200. So it is 1190 watt. Now, the purpose of the circuit is to provide power to component X. So provide power to this thing, and the power is this much. Determine the percentage efficiency. So this eta is equal to, this eta becomes power in X divided by the power input. This one here. So it is, let me write it as a power input, PI. So this PI will be equal to power input. This is 1190, and this thing is equal to this EMF into this. So it is 230 into 7 equal to divided 230 into 7. So it is 0.74 something, 0.7421 and so on. So it is simply 0.74. In terms of percentage, this becomes 74%. Now the last question. So it's a bit rigorous question this is. So in the last question we have the resistor of resistance 170 ohm. This thing is removed, leaving an open circuit in the lower branch, open circuit here. There is no change to the resistance of component X. So this is not changed. State whether the current in the power supply increase, decrease, or same. So that means if I remove this, there is only one path now. There are two paths initially. If I remove this, if there's a cut over here, there's only one path. So that means the resistance increases. So this resistance RAB increases. So I have this RAB, total RAB increases. So if this increases, now this RAB and this forms a voltage divider circuit of this EMF. So if this increases, then the total R loss increases. So if this R increases, the total R circuit increases. So R total increases. R total increases. And when it increases, the current decreases because EMF current is equal to EMF by R total. So this current is equal to EMF by R total. So R total has increased. That means I should decrease. So this will decrease the value of I. So that's the answer to this question.